Hello guys, welcome back to my channel. Today I'll be going over slope. So slope is a very fundamental concept in algebra, and it describes the steepness of a line, or how much the line goes up or down as you move from left to right. Right, so slope is represented by m. So m represents slope. So slope, you'll be seeing slope as described as two different ways. Right, so the first is rise over run. So this or rise divided by run, same thing. So this tells you that as much as you go up from one point on the line and you divide that by the run between those 2 points on the line, that will give you the slope, right? This will make more sense when I show you a couple examples later. And this is the easiest way to solve for slope given the graph and the points on the graph, right? The second way is the slope formula, also known as y2 minus y1 over x2 minus x1. So this is the slope formula, as I said before, and this is how you solve for slope when you're given two different points on the line, right? So this is the easiest way, but if you don't have a graph or anything and they just give you two different points, then you have to use this formula right here. So I'll just demonstrate the first part first, so rise over run. So let me erase this real quick. Then let's say we have a linear function like this. So this is our graph, let's say, and we have 2 points on that graph. There's 1 point here and 1 point here, right? So let's say this is 1 on the y-axis and this is 4 on the y-axis. And on the x-axis, let's say this is at 1, so this coordinate is 1, 1. And for this one, it's at 5. So the coordinate for this is 5, 4, and the coordinate for this is 1, 1. So now we need to solve for slope, we need to know the rise between these 2 points and the run between these points. So the distance between these points on the y-axis and the distance between these 2 points on the x-axis, right? So the rise from 1 to 4, so you just subtract 4 minus 1, that's 3. So it goes up 3. So our rise is 3. And then over the run. So how much do you run from 1 to 5? So 5 minus 1, that's just 4. So the slope of this line is 3 over 4. And I'll do one more example of this. So let's say we have another line, just this. So let's say we have a point here and a point here. So let's just say this is -1 and this is -2. And then here it is on the x-axis this is going to be 2 and then this is going to be 3, right? So we need to know the rise and the run between these 2 points. So the rise would be, so this is at -1 and this point is at 3, so you just subtract these two to find the rise, and we go 1 up to 0 and then 3 more up, that's 4. So rise is 4. And then our run, we go from -2 to 2. So on the x-axis, we go 2 to 0 and then 2 more to get to 2. So in total, that's a run of 4. So our slope is 4 over 4, and we can just simplify this for a slope of 1. Hopefully you guys understand rise over run now, and then I'll go forward to explaining the slope formula. So as I mentioned before, the slope formula is y2 minus y1 over x2 minus x1. So this is the more tedious way to do it, but you'll still have to do it because you won't always have a graph. So let's say I'll just do one example real quick. Let's say we have a coordinate of 1, 2, and another coordinate of -1 and 1, let's say. So first we just need to identify this. This isn't necessary, but we just want to keep this constant, keep this organized. The y2 and the x2 and the y1 and the x1 don't really mean anything. It just tells you to keep this and this constant. So whatever you pick to be the second coordinate or whatever you pick to be the first coordinate, you want to keep it like that. That's just what the y2, y1, x2, x1 means. Let's just assign these. So let's just say this is x1, this is x2, because this is x coordinate, y coordinate, and then this is x2 and y2. So now that we know that, we can start plugging this into our formula, right? So y2 here is 1, and then minus our y1 is 2. So 1 minus 2 over, or divided by, x2, which is -1, minus 1. And what is that equal to? So 1 minus 2, that's obviously -1. And then -1, remember to pay attention to the negatives. So -1 minus 1. So -1 minus 1, that would be -2. Pay attention to that because a lot of people get tripped up when there's negative numbers in the slope formula. You just need to pay attention to your signs. So we have -1 over -2. So that would simplify to 1 over 2. So that would be the slope between these 2 points, or the rate of change between these 2 points, right? Next I'll go over, there's a couple rules for slope, and well, I'll just explain that in the next section. So there's so first of all, there's positive slope, negative slope, and then zero slope and undefined slope. And I'll go over each one, and I'll also give you a visual representation to make it easier. Something with a positive slope. So let's say we have y is equal to 3x. So if you didn't watch the video on slope intercept form, I highly recommend you to watch it because it's pretty easy to understand. And if you watch that video, you would know that this coefficient is slope, right? So since 3 is a slope, you know that 3 is a positive number. So when we graph it, whenever we graph a positive slope, the rate of change will always be a positive number. So this is the line. So whenever the slope of a linear function, which is positive, would always look something like this. It might be steeper or shallower, but it will always go in that direction. And then let's say you have a function that has a negative coefficient or a negative slope. So let's just say it's -2x, right? So let me just draw a graph of that real quick. So whenever you have a negative slope, it will go the other direction. So it'll be the opposite of having a positive slope. So it looks something like this, right? The steepness, of course, isn't accurate, but I'm just trying to show you the difference between positive and negative. So now you can see side by side that the difference between the positive slope and the negative slope. So no matter what the coefficient is, as long as it's positive or negative, it will look something like this. The steepness would obviously change, but it would still be going in that general direction. So so the rate of change here, you see, as x increases, y also increases. But here, as x increases, y decreases. So the rate of change is negative, and here the rate of change is positive. So that's how you should think about positive and negative slope. And then I'll show you the difference between like having greater slope as compared to having a lower slope. So let's say let's compare two linear functions, right? So let's say we have y is equal to x and y is equal to uh 5x, right? So I'll show you the function, the graphing of a function y is equal to x. So y is equal to x is what we call the parent function. So the function without any changes. So it will look something like this, and each value would be corresponding. So let's say this is 1 1, this is 1 2, something like this, right? So this is 1 2 3, 1 2 3. So the graph would look something like this. So it would be 1, a point here, a point here, a point here. It'll look something like this, right? So that's y is equal to x. But for y is equal to 5, so this is a normal slope, I guess you could say. But for y is equal to 5, it would be much more steeper because the slope is greater, right? So let's say this is 0 0, and then for the rise over run, the rise over run for this is 5 over 1. So every 1 you go over, you go higher 5. So the rise over run is 5 over 1. So we would run 1, so we would go x over 1. The on the x-axis we go over 1, then we go 1 2 3 4 5. So the first point would be here. So you can already see the difference, how much more steeper this line is. So the general line would look something like this, right? So that's just a greater slope compared to a less slope. But what if this was a fraction? Now, I'll show you this compared to y is equal to x. So let's say we have y is equal to 1/2 x. So in this situation, the slope for this line would be flatter than this line, or less steep than y is equal to x. So let me just draw that out. So so the rise over run of this is for every 2 you run, you rise 1. So let's just start from 0 0 here. So um you run 2. So you'd run 2. So this is, let's just say this is 2, and then this is 1. So you'd go over 2 up 1, right? And then let's say this is 4, and this is 2. So you go over 2, up 1. So there's something like that. So you can see how much more flatter this line is. I mean, it would, my drawing isn't that good, but it would show up better in a graphing calculator. But so you can play around with that if you want, if you'd like to see a better representation. I personally use Desmo's graphing calculator. It's a free calculator you can use, so you can just hop onto that and see if it see the difference between this stuff. So the next thing I need to cover is zero slope and undefined slope. Okay, so undefined slope is something that you don't see very often. I mean, it still counts as a linear function, but it's most of the linear function you will see is just gonna be a normal linear function with a non-zero slope. But you'll still need to know both undefined slope and zero slope. So let me just start off with undefined slope. So undefined slope, the equation for it looks a little bit different because it's just a vertical straight line like this. So some of you might know that this isn't an actual function. And this is just, let's say this is at this point where it intersects the x-axis at is 5. So the equation for this would just be x is equal to 5. So every single y value on this graph infinitely, each of those y values would come at 5. And if you know from a function, any function, that isn't possible, because in functions, an x value can never have multiple y values, or infinite y values, because in this case, 5, the x value of 5 has infinite y values. So you know this isn't an actual function, and therefore the slope or rate of change of this function is undefined. Because if you think about it, if you think about trying to apply rise over run to this, let's say we rise infinitely, so the rise would be like, uh, the rise is infinite. We have an infinite rise, and then we run 0. So, or like, let's say from this point to this point. So let's say this is like 2 on the x-axis, 3 on the x-axis, and this point is 0 on the x-axis. So let me erase that real quick. The rise between 0 and 3 is 3, but it has no run. It didn't go over, it didn't shift over the x-axis, so it's 0. So you can 3 divided by 0 is impossible. If whenever 0 is in the denominator, or you're trying to divide something with 0, or 0 is a divisor, then the answer is always going to be undefined, because you can't physically divide by 0. So that's what undefined slope is. But zero slope is a little bit different, because it actually is a function. It counts as a function, but it's a little bit different, because something with zero slope would look something like this. It would just be a flat line. It would be parallel to the x-axis. So the equation, the way we would represent this, so let's say this is at 2, it intersects with the y-axis at 2, so it would be y is equal to 2. So every single x value is equivalent to 2, but this still counts as a function, because each x value only still has one y value. It's not going to be that different x values can still be equivalent to the same y value, but one x value can be equivalent to multiple y values, if you try and kind of understand that. So it would just be a flat line. How this still counts as a function, but it's a flat line. And you know that the rate of change of this is going to be 0, because it's just a flat line, but I'll just show you a bit. So this is y is equal to 2, and x 0, 2, so the coordinate for this point is 0, 0, 2, and then let's say this point is I'll just say 5, 2, right? So we know the rise is going to be 0, so it's going to be 0 on the top, and then since we went from 0 to 5, the run is 5. So you can do 0 divided by 5. So this is possible to do, and this would just be 0. But you can't do it the other way around, because you can't divide anything by 0, but 0 can be divided. It's kind of weird to think about, but it's just fundamental rule of math, and you just have to stick with it. So that's the difference between undefined slope, zero slope, a greater slope, a less slope, positive slope, and negative slope. Thank you for watching, guys, and that's the breakdown for one of the most fundamental concepts in algebra and in linear functions. You need rate of changes and slopes throughout your mathematical career, throughout middle school and high school, and this is just a very basic fundamental building block of it. Let me know if you guys want any other videos, and thank you for watching.